So welcome back, ladies and gentlemen. You don't realize that this is our second attempt at doing this question. Example 2 found on the graphs of quadratics, found on page 2. I'll read the question to you. We're trying to find the equation of the parabola in vertex form. And this parabola passes through the point of negative 320 and has the zeros of 2 and negative 1. So although they want it in vertex form, we actually cannot use the vertex form directly. Okay? So we have to actually use something like we taught in grade 10, which is the factored form equation. So let's just write that out, and let's go from here. So going backwards from the roots of the zeros or x-intercepts, I'll just check this off in orange. Notice what I'm going to do, ladies and gentlemen. There are so many letters. And put the x's there. And this is 2. So notice what I'm going to write. I'm going to write minus 2. Notice this is negative 1, so I'm going to put plus 1. This is actually using the zeros. And a lot of you realize now, well, what are we going to do next? There's still x's and a's and y's. So notice I now have to use this negative 320. What is the negative 3? The negative 3 is our x, and the 20 is our y. So 20 is here, equal to a, negative 3, minus 2, negative 3, plus 1. And notice, even though they want the equation in vertex form, we have to find what a is. We have to find what a is. Don't get me wrong, there's something else we can also do. Let's just pause here for a second to make sure I'm doing this right. And then we can keep on going. So 20 is equal to a, that's negative 5, that's negative 2. Much better. Negative 5 times negative 2 is positive 10, so we get 10a. Divide both sides by 10, a is equal to 2. Therefore, in factored form, we have y is equal to 2, x minus 2, x plus 1. Now again, notice this is not the answer we're looking for, but I think a lot of you remember doing this in grade 10, finding something in factored form. So what do we do next? Well, we want to find the coordinates of the vertex. And then, although we could expand this and then complete the square, that's a little silly. We already know that the zeros are related to the axis of symmetry. The axis of symmetry is the x-coordinate of the vertex, and what it does is we add those two roots together and divide by 2. In this case, the axis of symmetry is x is equal to, what are the roots? Negative 2 plus 1 dividing it by 2. Make sure I did that right. No, it's the other way around. Negative, no, you still remember negative. 2 plus negative 1. My brain is going crazy. Can someone double check that I covered that right? Are those the zeros? 2 and negative 1? Thank you. So we add the two roots together, 2 and negative 1. 2 plus negative 1 is 1. 1 divided by 2 is 1/2. Right? So we have partially of the vertex, right? That's the x-coordinate. But notice what we have? We have an equation where we can plug this in and find out its y. So sub x equals 1/2 into the factored form. So what do we get? Y is equal to 2 times 1/2 minus 2, 1/2 plus 1. Before we continue, everyone okay so far? Y is equal to 2. 1/2 minus 2 is negative 3/2. 1/2 plus 1, 3/2. So far so good? And then y is equal to negative 9 over 4. Cross out the 2, so this 2 can go out because notice it's a 2 over 1. 2 is divided out. So negative 9 over 2. So double check my math for me from the class. Is that right? You don't care. And so therefore, the vertex form is y is equal to 2 x minus 1/2 squared minus 9 over 2. And finally, now we have to draw it. Let's draw it up here. Negative half to be over here, let's just say. Negative 9 over half would be over here. And it opens up, so it's a parabola there. Something like that. What's the domain? The domain is x belongs to all real numbers. And the range, y is greater than or equal to negative 9 halves, such that y belongs to real numbers. It's not the best, but who cares? And that's example 2. Take 2.